Hello and welcome to section 1.4 on measurement. This will be a little bit of a review to start with. Obviously you all should be very familiar with SI, units of measurement. When we want to know how long something is, we measure in meters for length. If we want to know the time, we use seconds, kilograms for mass. And those are the standard SI units because those are the units that are universally accepted and used in science and industry. Sometimes the units are combined. There's a combination of different units like meters per second squared, or joules times meters per second squared, and they combine to form other units that will be used in science and industry as well. But these are the standard units of measurement. Just interesting little facts that you might like to know how they came about. The original standard for a meter was 1/10,000,000th distance from the equator to the North Pole. That was changed. The current standard now is the distance traveled by light in a vacuum in 3.3 times 10 to the negative 9th seconds. That's what a meter is defined as being. These standards are very important because it's important for scientists and other people, engineers and people in industry, to have very, very consistent results. And every meter stick, every kilogram mass, every clock in the world is calibrated to these current standards for length, mass, and time. For mass, the original standard was 0.001 cubic meters of water. The current standard, and the way that it is calibrated, mass is calibrated, is the mass of a very specific platinum-iridium alloy cylinder. So they have that very special cylinder that we all calibrate our mass against. Time used to be the original standard 1/60th times 1/60th times 1/60th average solar days. The current standard, however, is this very large number times the period of a radio wave emitted from a cesium-133 atom. So scientists are constantly working on ways that they can be more and more precise and maintain good standards of measurement. Common SI units of measurement, you should be familiar with some of these certainly. In physics, we'll be using meter, kilogram, second. We'll learn about some of these. You already know about moles here, and Kelvin for temperature. We'll look at amperes later in the year, light intensity, candela as well, volume, liters. Now, one thing that's really important, if you did not learn this really well, make sure that you can write in scientific notation. It's really important because I dare say you would not want to write a giga of anything out or an atto of anything out. Those numbers are just ridiculously large and ridiculously small. So right here, when we can write things in 10 to the 24th or 10 to the minus 21, that makes our life a lot easier. I am never going to ask you to memorize all of these different prefixes, but they're here for you to use as reference because you will come across them occasionally. In physics, we tend to deal in extreme large sizes and extreme small sizes. So here you can see that, let's see, where are we? Right here would be the center line. And coming out from there, you're going to get into the smaller numbers and the larger numbers here. So these are the symbols for these different prefixes. Again, sometimes there's a little discrepancy. I don't know which country spells it quite like that, but in English it's MICRO, not with a K, and it's abbreviated with the Greek letter mu. So just be familiar with some of these. I do expect that you definitely know how to convert between the unit and a kilo of that unit, so a gram and a kilogram, or also millimeters and centimeters, that you understand how to convert between the milli, the centa, and the unit itself as well. Those should be second nature and come to you easily. If not, make sure you study those. Always remember when you're calculating, making any kind of calculations, include units. Units are absolutely as important as the dimension because running 10 kilometers is not the same as running 10 millimeters. I hope you can appreciate the difference there and make sure you always include your units. Advanced ideas, there's a quick lab on page 12 in your textbook. Look into more interesting facts about standard units. What are some other standards? How were they developed? How have they changed over time? I'd love to see what you come up with, and I look forward to seeing you in class.